In our previous lesson, we had written code to insert a node at the beginning of the linked list. Now, in this lesson, we will write program to insert a node at any given position in the linked list. So let me first explain the problem in a logical view. Let's say we have a linked list of integers here. There are three nodes in this linked list. Let us say they are at addresses 200, 100 and 250 respectively in the memory, and we have a variable head, and that is pointer to node, that stores the address of the first node in the list. Now let us say we number these nodes, we number these positions on a 1 based index. So this is the first node in the list, and this is the second node, and this is the third node, and we want to write a function insert that will take the data to be inserted in the list and the position at which we want to insert this particular data. So we will be inserting a node at that particular position with this data. There will be a couple of scenarios. The list could be empty, so this variable head will be null, or this argument being passed to the insert function, the position n, could be an invalid position. For example, 5 is an invalid position here for this linked list. The maximum possible position at which we can insert a node in this list will be 4. If we want to insert at position 1, we want to insert at the beginning, and if we want to insert at position 4, we want to insert at end. So our insert function should gracefully handle all these scenarios. Let us assume, for the sake of simplicity, for the sake of simplifying our implementation, that we always give a valid position. We will always give a valid position so that we do not have to handle the error condition in case of invalid position. The implementation logic for this function will be pretty straightforward. We will first create a node. Let's say in this example we want to insert a node with value 8 at third position in the list. So I'll set the data here in the node. The data part is 8. Now to insert a node at the nth position, we will first have to go to the n minus 1th node. In this case, n is equal to 3, so we will go to the second node. Now the first thing that we will have to do is we will have to set the link field of this newly created node equal to the link field of this n minus 1th node. So we will have to build this link. Let's say the address that we get for this newly created node is 150. Once we build this link, we can break this link and set the link of this newly created node as address of this, set the link of this n minus 1th node as address of this newly created node. We may have special cases in our implementation, like the list may be empty, or maybe we may want to insert a node at the beginning. Let's say we will take care of special cases, if any, in our actual implementation. So now let's move on to implement this particular function in our program. In my C program, the first thing that I need to do is I want to define a node. So node will be a structure. We have seen this earlier. So node has these two fields, one data of type integer and another next of type pointer to node. Now to create a linked list, the first thing that I need to create is a pointer to node that will always store the address of the first node or the head node in the linked list. So I will create a struct node star. Let's name this variable head, and once again I have created this variable as a global variable. To understand linked list implementation, we need to understand what goes where, what variable sits in what section of the memory, and what is the scope of these variables, what goes in the stack section of the memory and what goes in the heap section of the memory. So this time, as we write this code, we will see what goes where. In the main method, first I'll set this head as null to say that initially the list is empty. So let us now see what has gone where so far in our program, in what section of the memory. The memory that is allocated to our program or application is typically divided into these four parts or these four sections. We have talked about this in our lesson on dynamic memory allocation. There is a link to our lesson on dynamic memory allocation in the description of this video. I'll quickly talk about what these sections are. One section of the application's memory is used to store all the instructions that need to be executed. Another section is allocated to store the global variables. that live for the entire lifetime of the program, of the application. One section of the memory, which is called stack, is used to store all the information about function call executions, to store all the local variables. And these three sections that we talked about are fixed in size. Their size is decided at compile time. The last section, that we call heap or free store, is not fixed, and we can request memory from the heap during runtime, and that's what we do when we use malloc or new operator. Now I have drawn these three sections of the memory: stack, heap, and the section to store the global variables. In our program we have declared a global variable named head, which is pointer to node, so it will go and sit here, and this variable is like anyone can access it. Initially value here is null. Now in my program what I want to do is I first want to define two functions, insert, and this function should take two arguments: data and the position at which I want to insert a node, and insert that particular node at that position, insert data at that position in the list, and another function print that will simply print all the numbers in the linked list. Now in the main method I want to make a sequence of function calls. First I want to insert number 2. The list is empty right now, so I can only insert at position 1. So after this, insert list will be having this one number, this particular number 2, and let's say again I want to insert number 3 at position 2. So this will be our list after this insertion, and I will make two more insertions, and finally I'll print the list. So this is my main method. I could have also asked a user to input a number and position, but let's say we go this way this time. Now let us first implement insert. I'll move this print above. So the first thing that I want to do in this method is I want to create a node, so I will make a call to malloc. In C++ we can simply write a new node for this call to malloc, and this looks a lot cleaner. Let's go C++ way this time. Now what I can do is I can first set the data field and set the link initially as null. I have named this variable temp1 because I want to use another temp variable in this function. I'll come to that in a while. We first need to handle one special case when we want to insert at the head, when we want to insert at the first position. So if n is equal to 1, we simply want to set the link field of the newly created node as whatever the existing head is, and then adjust this variable to point to the new head, which will be this newly created node, and we will be done at this stage, so we will not execute any further and return from this function. If you can see, this will work even when the list is empty because the head will be null in that case. I'll show a simulation in the memory in a while, so hold on till then. Things will be pretty clear to you after that. Now for all other cases, we will first need to go to the n-1th node as we had discussed in our logic initially. So what I'll do is I'll create another pointer to node, name this variable temp2, and we will start at the head, and then we will run a loop and go to the n-1th node, something like this. We will run the loop n-2 times because right now we are pointing to head, which is the first node. So if we do this temp2 equal temp2.next n-2 times, we will be pointing temp2 to n-1th node. And now the first thing that we need to do is set the next or the link field of newly created node as the link field of this n-1th node, and then we can adjust the link of this n-1th node to point to our newly created node. And now I am writing this print here. I have written this print here. We have used a temporary variable, a temporary pointer to node, initially pointed it to head, and we have traversed the whole list. Okay, so let us now run this program and see what happens. We are getting this output which seems to be correct. The list should be 4, 5, 2, 3 in this order. Now I have this code. I'll run through this code and show you what's happening in the memory. When the program starts execution, initially the main method is invoked, some part of the memory from the stack is allocated for execution of a function. All the local variables and the state of execution of this function is saved in this particular section. We also call this stack frame of a function. Here in this main method we have not declared any local variable. We just set head to null, which we have already done here. Now the next line is a call to function insert. So the machine will set the execution of this particular method main on hold and go on to execute this call to insert. So insert comes into this stack, and insert has couple of local variables. It has two arguments, data and this variable n. This stack frame will be a little larger because we will have a couple of local variables. And now we create this another local variable which is a pointer to node temp1, and we use the new operator to create a memory block in the heap. And this guy temp1 initially stores the address of this memory block. Let's say this memory block is at address 150, so this guy stores the address 150. When we request some memory to store something on the heap using new or malloc, we do not get a variable name, and the only way to access it is through a pointer variable. So this pointer variable is the remote control here, kind of. So here when we say temp1.data is equal to this much, through this pointer, which is our remote, we are going and writing this value 2 here, and then we are saying temp.next equal null. So null is nothing but address 0, so we are writing address 0 here. So we have created a node, and in our first call n is equal to 1, so we will come to this condition. Now we want to set temp1.next equal head. temp1.next is this section, this second field, and this is already equal to head. Head is null here, and this is already null. Null is nothing but 0. The only reason we set temp.next equal head will work for empty case is because head would be null. And now we are saying head is equal to temp1. So head guy now points to this because it stores address 150 like temp1. And in this first call to insert, after this we will return. So the execution of insert will finish, and now the control returns to the main method. We come to this line where we make another call to insert with different arguments. This time we pass number 3 to be inserted at position 2. Now once again memory in the stack frame will be allocated for this particular call to insert. The stack frame allocation is corresponding to a particular call. So each time the function execution finishes, all the local variables are gone from the memory. Now once again in this call we create a new node. We keep the address initially in this temporary variable temp1. Let's say we get this node at address 100 this time. Now n is not equal to 1, we will move on to create another temporary variable temp2. Now we are not creating a new node and storing the address in temp2 here. We are saying temp2 is initially equal to head, so we store the address 150. So initially we make this guy point to the head node, and now we want to run this loop and want to keep going to the next node until we reach n-1th node. In this case n is equal to 2, so this loop will not execute this statement even once. n-1th node is the first node itself. Now we execute these two lines. The next of the newly created node will be set first, so we will build this link. Oops, no, temp2 dot next is 0 only, so even after reset this will be 0. And now we are setting temp2 dot next as temp1, so we are building this link. And now this call to insert will finish, so we go back to the main method. So this is how things will happen for other calls also. So after everything we have inserted, when we will reach this print statement in the main function, our list will be something like this in the memory. This is a little messy. I've chosen this addresses as per my convenience for the sake of example. And now print will execute, and once again I'm using a temp variable in print. By now it should have been clear to you why we use temp variable again and again, and why this variable head that stores the address of the first node is so important. Now what if this head was not global? What if we would have declared this head inside the main method? We have talked about this in our previous lesson. Head will not be accessible everywhere, so in each call to these functions, in each call to insert, we will have to return some value from the function to update this head or we will have to pass this head by reference. We have talked about this in our previous lesson. So this is it for this lesson. In our next lesson, we will see program to delete a node at a particular position in the list. So thanks for watching.